So, this is the light reaction, and we're going to interview all of our cast members. We are right now in the Magic School Busing, the thylakoid space. This is where photosynthesis is happening and beginning. So that's the stroma. These chairs represent the thylakoid membrane. And we can see we've got some on the outside, some on the inside. Yeah, you should be right there, right? Okay, hi, how are you? Okay. All right, and then we have this space called the thylakoid lumen, and that's the space inside of the thylakoid. And the thylakoid is a little disc, and a stack of them are called granum. So I'm going to interview some of my cast members here in this sketch, and we'll begin obviously with the sun. It's a good Catholic school, so we should start with the sun. All right, not that sun, but anyway, sorry, that's my religious humor. Go.
So I'm the sun, and my job is to send photons to the photosystem 2 and 1.
Okay, cool. And we'll slide over here to you. You're next, right?
I'm the Z protein. I split the water molecules into O2, oxygen, hydrogen, and electrons.
Okay, can you show us what particles we're using to represent those things?
So the green's the electrons.
Okay.
The hydrogen is the red, and the oxygen is the blue.
Perfect. Okay, great. And then what?
I'm the photosystem 2, and when photons strike me, it excites the electrons in my chlorophyll P680, and then through redox reactions, I transfer the electrons to plastoquinone.
Okay, and that is you.
Hi, my name is plastoquinone. I am an electron carrier. I pick up 2 high-energy electrons from photosystem 3P680, grab 4 H ions from the stomata, and take them all the way to B6F complex. I am located within the thylakoid membrane.
Okay, so you just kind of shuttle back and forth. You don't use any of those energies.
I just shuttle them.
Okay, all right, great. Cool. And you are, sir?
I am the B6F complex. I receive 2 electrons from the plastoquinone, which is right here, and I pump out 4 hydrogens from that she gives me into the thylakoid lumen, and I take the 2 electrons she gave me originally and give them to the plastocyanine, which is out here located in the thylakoid lumen.
Okay, and shouldn't you be a little bit closer to the membrane? There he is. Okay, good. Hey, how you doing? Your name is?
Plastocyanine. I take 2 electrons from the P6F complex, and I hand them off to the photosystem 1 piece.
Okay, so you slide along there? Cool. Yeah. And then you are?
I'm the photosystem 1. I receive 2 low energy electrons from plastocyanine
Yep.
and photons of energy from the sun that energizes the 2 electrons, and then I pass them to ferredoxin on the stromal side of the thylakoid membrane.
Beautiful. Okay, and that's you, right?
I'm ferredoxin, and I take the 2 electrons that I get from photosystem 1P7, and I slide them over on the stroma. I'm in the stroma, and I slide them over to the NADP reductase.
Okay, cool. And who's that? Hey.
I am NADP reductase. I use 2 electrons and proton ions from the ferredoxin in the stroma to reduce NADP plus to NADPH.
Awesome. And?
So I'm NADP positive. I take 2 high-level electrons from the NADP reductase and 1 proton from the stroma to become NADPH, and then I go off to the Calvin cycle.
Okay, cool. And you are?
I'm ATP synthase. I take the proton gradient out of the thylakoid lumen into the stroma and then combine PI and ADP to create ATP.
Okay, cool. And you are, sir?
I am ADP and pi, and I pass these on to the ATP synthase to create ATP, which creates glucose.
Okay. In the Calvin cycle, right?
Yep.
Yeah, okay, so ATP and NADPH for the Calvin cycle. And those are what we call the dark reactions. These are the light reactions and our cast members. Thank you for your interview.